Hello everyone. So today the problem which we will solve is the third problem of this bi-weekly contest. And let's look at the problem. It's called House Robber 5. So what does the problem state? That you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed and is protected by a security system with a color code, right? So you are given two integer array. One is called nums and second one is called colors of length n, where nums of I is the amount of money in the ith house and color of I is the color code of the house, right? You cannot rob two adjacent houses if they share the same color code, right? Return the maximum amount you can rob, right? Let's look at the example. Like this example, if you look at this, right? So what is the valid or the maximum amount of money that you can steal? First, if you pick up this house, right, this color one, you will get rupees 4. And after that, if you pick this house, you will have a color code of 2, and 1 and 2 are not same, and the total money that you will get is 4 plus 5. Wait, let me just quickly show you this. Uh, if I paste it here, right? All right. So it's okay now. Oh, sorry. Yes. So what does this mean? The problem, first you understand the problem was written in a bit vague manner. I think could have written it in a better way, but what they mean by this is this line is very important, that you cannot rob two adjacent houses if they share the same color code, right? Means if you, let's say, rob the ith house, then the I plus 1th house should be of different color. If you want to rob this, you can skip this as well, but if you want to rob this, then let's say this color was let's say 2, then this should not be 2 if you want to rob this, right? This should be 3, 1, anything it could be, but not 2, right? So let's say if you have robbed this house, then if you want to rob this house, then the color code should not match. This is what they meant. And let's say if you were on ith index and if you are now on I plus 2th index, right? And this here it was I plus 1, right? So what are they trying to say over there is that if you, let's say, robbed this house, right? If you robbed this house, then you can easily, and let's say this house had a color code of 2 and this house also had a color code of 2, right? And if you robbed this house and you, let's say, you wanted to skip this house, you said no, I don't want to pick this house, let's say, right? So you can skip this house and you can rob this house with a color code of 2. That is what the question meant. They meant that if you want to rob two adjacent houses now, then they should not have the same color code. That just was the problem statement. So if you look closely, like while I was explaining the problem statement to you as well, I was saying that if you want to pick this or if you don't want to pick this, because this is a classical DP problem of pick, not pick. If you don't know, no worries. This is an abstract problem. I will easily make you understand how to solve this problem, right? Now, when you face these types of problem where you are given a house and like anything, and you can like rob, you can take any value of your choice and you can skip any value. Like they have not said you that you need to pick every houses, or they have not given you any restriction on something, right? So whenever you have these type of condition, na, the first thing that should click in your mind is recursion. Now, why do I say recursion? Try to understand this, right? Recursion. Why recursion? Because for every house, there are possibilities that, let's say, you want to pick this house, right? Either you, if you see the, oh no, the value of house is very low, means the rupees that you are getting is, let's say, only 1. And if you leave this house, now this adjacent house of this was, let's say, rupees, let's say 100, right? And both have a same color code. Let's say it had a color code of 1, this also had a color code of 1, they were adjacent houses. Now you tell me, which house should you rob, right? Even though we are not the robbers, but we know that picking this house is definitely helpful for us, right? What a strange day that on a Valentine's Day we are solving a house robber problem. Anyways, so we can pick this house, right? So we had the opportunity to skip this house, right? We can skip this house and move to this one, right? Okay, so we can understand that this problem involves either picking up element, right? Either pick or you don't pick, right? Let's say not pick. So this is a classical problem. I hope you understand why this concept has been involved of picking and not picking the thing, right? So, okay, we know that when we have this opportunity, there are 2 to the power n possibilities. And if we optimize this one, right, I will show you how it's done. If you don't know, no worries. But let us say that there was house. Let's say what the example what I was taken. Let's take this example. It is a great one. The third example was a great one. This made me understand many things, right? Let's say, uh, right. Let's now zoom it. Now what they're trying to say is, if you look, they are saying that you can rob the house, uh, first one colored house, then you can skip everything, and then you can again rob, then you can skip this one, right? You don't need to pick this one. Then if you don't pick this one, right, then this house had a color one, right? And if you skip this one, then now you don't have any restriction of same color, right? This house had it any color been, right, it was one, right? Still you can pick it, because why? Because this house is not adjacent to the one that you picked earlier, right? What 10 was at index 0, right? And 3 is at index 2, right? So we can easily say that we can pick this element. Why? Because we have not picked the last element which was adjacent to this, right? And even though it had same color, there is no issue in that, right? They have explicitly mentioned that, okay, you can pick this house, right? They have said you cannot rob two adjacent houses, right, if they had same color code. So I hope this part is clear, right? So we can pick up this 3, right? And after this 3, we can pick up this 9. Why? Because this had a color code of 2. And see, 3 and 9 are adjacent and they don't have a same color code, right? So I hope here you can see what are the changing things, right? While you are traversing on the array, you saw that, okay, I was changing index, right? Index was changing every time, right? So let's say my function was solve, right? Now in my solve function, I had index, which was a changing state. And besides that, we can also see that which other part is the changing thing in our recursive solution. So if we look closely to it, we also need to keep track of the element which we picked earlier, right? So let's say we picked 1, right? So you need to store like previous value. What was the previous value, right? All right. Okay, we need to store the previous value. But what if, let's say, you skipped this element, right? So in that case, if you skip any element, then you don't need to store the previous value. I will come to the optimization step. This is how I thought the problem statement. And this is when you are solving these types of problems, right? You need to be prepared how the interviewer can ask you, right? How did you come to the approach? Optimized approach should be a later part, right? So if you look at this, you need to store the previous value, right? Let's say you picked up this one, right? And after picking this one color code, if you go on this one, this index, then now you need to store the previous value, right? If the previous value is 1, then you can't pick, right? And let's say if you thought, let's skip this, right? Let's 10, 1, 3 and 9, right? This is what I'm trying to convey. Let's say you picked up this element, then you need to have your previous value will be 1, right? When you go to this element, your colors is 1, right, at this moment, and your previous value is also 1, means you can't pick this element. You are restricted to pick this element, right? And when you don't pick this element, you move to the next index. Now your previous element has vanished because it is not adjacent anymore, right? Then the last element you picked up is not adjacent to this, right? So now previous value becomes, let's say, -1, right? So now, is this value same as this? No. -1 is not equal to 1. So you can pick this element. You picked up 3, right? Now your previous val becomes 2. Sorry, 1, right? And then you move to the next index, 2. Now this is also not equal to previous value. So you can again pick this one. So you will pick this one. And these are the 3 values that you will pick, which will yield you 22, right? Now, if you know a bit about DP or something, you can say the changing state, right? What are the, when you write a recursive solution, you need to understand what are the changing variables or changing things in the recursive solution. If you look at closely at it, the index is changing state and the previous value was a changing state, right? And if you look at the time constraints which was given to you in the problem statement, it was nums dot length equal to colors dot length will be 10 to the power 5, means index can go till 1e5, right? And your num's color value can also go till 1e5, right? So you wrote a solution which was 1e5 cross 1e5, right? When you, if you know that in whenever we are creating recursive solution, and if we optimize this also, na, it will be big O of n square, right? Because I index which is changing and the value which is changing, these are the two changing state, and it will yield us big O of n square. And big O of n square means 1e10, right? 1e10 will give you a TLE, right? So you need to optimize this. Now think of this, how can you optimize this, right? If you look, you can't, like, तुम index को नहीं छेड़ सकते, right? Index will be changing, right? Index will be changing. But what the thing is now, the flag, you can take a flag variable. Now, how did I suddenly jump into the flag variable, and what did I thought in the contest process, right? So while I was solving, I thought, let's say if I had an element like this, let's take this test case only 10 1 3 9. Let me write it down: 10 1 3 and 9, and colors was 1 1 1 2 if I'm not wrong, right? So 1 1 1 2, right? So let's say if you picked this element up, right? When you are picking this element, then you can say, okay, if I pick this element now, I just need to store, I will say my flag is equal to 1, right? And if flag is equal to 1, that means you picked the last element. What does this mean? You picked the last element, right? I hope this makes sense to you. You pick the last element, right? All right. And if you, let's say, when you pick this 10, I'm taking this test case as the best case scenario, right? Let's say you had 10, you picked this up, right? If you pick this up, you will say my flag was 1, I'm writing F, and the value which will be added to your answer is 10, right? And let's say if you didn't pick up, right? Let's say NP. If you didn't pick this up, then flag will be 0, right? You won't have any restriction, but the value added will be 0, right? Then you, from 10, you go to the next state, right? What is the next state? Next value is 3, right? If I'm not wrong, next value is 1, sorry, 1, and the color is also 1. So what you will check is, now, if your flag is 1, yes, your flag was 1. And if your flag was 1, you just need to check. What do you need to check if your flag was 1? You just check that if my previous element means colors of I minus 1, that too is what adjacent means, right? If colors of I minus 1 is equal to colors of I, that means these two values are same. And if these two values are same, then you can't pick. This is the restriction, right? So simply you will say, then when you come at this, you will check, okay, my flag is equal to 1. I just need to check if my colors of I minus 1, whichever index you are currently standing at, you will be standing at this index, right? You will check, you will see, yes, my flag is equal to 1. Let me check of index of I minus 1. Index of I minus 1 has a color of 1. What does this mean? You can't pick this color, right? So you need to skip this element. You are bounded to skip this element. And when you skip this element, what happens? Your flag resets to 0, right? And your flag resets to 0. That means now you have not picked this element. This is not an adjacent anymore, so your flag will be 0. So whenever my flag will be 0, I am free to pick that element, right? I'm free to pick that element. And whenever I pick that element, what happens? I will do a nums of add index that will be added to my value, right? But इसके साथ ही साथ क्या होगा, जो solve function, whatever the solve function I had, right, it will go to index plus 1, and the flag will change to 1. Flag changing to 1 means what? Let me define it. I have defined it already, but flag changing to 1 means I am at the index, I am at currently at index I plus 1, at, or rather index, any index, let's call it I. I am at index I, and flag is equal to 1 means I have picked the last element. That's it. I have picked this last element, right? And if I comma 0, that means I am at the ith index and I have not picked the last element. That means I'm not bounded to pick or check anything, right? That's it. These state will easily solve the problem. Let's look at small test case, right? Let's say I had only 10 and 1, right? I'm not solving the complete problem because the tree will be big. I hope you can understand this, right? So if you look, let's say 10 and 1, right? And the values are 10 and 1, and both have the color 1 comma 1, right? Just for the sake of understanding, right? So when we are at 10, let's say we pick this element, then what happens is you get a plus 10 and your flag becomes 1, right? Then at you go to the next element, right? You had the opportunity to pick and not pick, right? The element value, the color you will now, if your flag is 1, you will check if my colors of I minus 1 is equal to I. Yes, it is I. So you can't pick this up. You need to say, okay, 0 plus solve, right? Go to the next function. You will say go to the next index with a flag value of 0. But why flag changed to 0? Because you can't pick this element, so you moved on. And if you decide not to pick up, it will be same as this, right? Let's say you didn't pick it up, right? Let's say you have not picked it up. Then what will happen? 0 will be added to the solution answer, and solve function will call, okay, go to the next, 0 will be added, and you will go say, okay, go to the next value with a flag of 0, right? So it will be 0, sorry, I plus 1 comma 0, right? I hope this point is clear to you. And when you go to the next element, now you have the opportunity to pick this element or skip this element. Let's say you came at 1. Now you can either pick this up or you can skip this, right? And you can think of what can be done, right? You can pick this element, you will get +1. If you skip, you will get 0. And ultimately, what you will return? You will return the maximum of all of these, right? Maximum of pick comma not pick. Why maximum of pick comma not pick? I hope this is clear. I don't think you need to understand that why we need to max, because the problem only stated, right, that you need to maximize the value that you had, right? So I hope the problem statement and examples were clear how this was done. So what I'm doing is I'm creating a solve function, right? Now in this solve function, what I will do is uh, basic recursion solution, right? Let's say I have marked this as, oh, first let me quickly discuss the time complexity as well, right? So now what are the changing states? You can say solve function had a index and a flag, right? Index could go up to 1e5, and flag will either have a value 0 or a 1, right? So it has two values, so it will be big O of 2 into n, right? Which is ultimately big O of n. And for 1e5 this will be accepted, right? So let's look at the test solution, right? So what is my base case? That if I have reached the end of the array, if you have reached the end of the array, simply return a 0, right? And now if flag is equal to 0, what does this mean? You don't have any restriction, you can pick the element. So you will pick this element, you will add nums of index and call the solve solution, which will be index plus 1, means move to the next index, and flag becomes 1, right? Because if you have picked the element, you just need to store, okay, I have picked this up, and the last element's flag is, now the flag is 1, so you have a restriction, right? And else if my flag is equal to 1, right? If my flag is equal to 1, then if color of flag is equal to 1 means you have picked the last element. That's it. So if color of index is equal to color of index minus 1, if it's not equal to, sorry, if the value means color of index is not equal to previous index color, then you can again pick the element, right? And if you pick the element, flag will be 1, right? I hope this is making sense to you, right? And you always had the opportunity to not pick, and if you don't pick the element, you will go to the index plus 1 and with a value of 0, right? And simply you will return pick max of pick comma not pick, right? And how the DP state is changing, that's what I have said. The DP state is changing like if the DP of index is changing and flag is changing, right? And if it is not -1, you will simply return it. I hope the memoization part you know it. If you don't know, ping me in the comment or write a comment. I will try to make you understand. It's simple, very simple. If you understood the recursion, just two lines you need to add, right? If DP of index and flag is not equal to -1, you will return that, and at the end you will return DP of index flag as max of pick comma not pick. And if you run this will get accepted as well. I have already done it, right? It is accepted. So I hope the problem was clear to you and you understood the solution as well, and the time complexity was clear to you. Thanks for watching. If you understood, please subscribe. And if you have any doubts, you can ask in the comments. Thanks for watching.